codominance and incomplete dominance. Well, first of all, we're going to start with incomplete dominance, and we're going to go with the classic snapdragon example. Snapdragons can come in red, white, or pink colors. If a snapdragon gets a CR allele from one parent and a CR allele from the other parent, then that snapdragon will be red. If they get a color white allele from one parent and a color white allele from the other, the snapdragon will be white. Now, if they're heterozygote and they get a CR from one parent and a CW from the other parent, then in this instance, one of these is not completely dominant over the other. It's incomplete dominance. And what you have with incomplete dominance is a heterozygote, a heterozygote that is in between or a blend of the two homozygotes. So if you were going to mix red and white or go kind of halfway in between, you're traveling from red to white and you get halfway there, you end up with pink. And that is the case with our snapdragons. This is called incomplete dominance. So let's do a problem. Let's cross two pink snapdragons. So CR, half of the mom's eggs are going to be CR, and half of her eggs are going to be CW. Half of the pollen, or sperm, is going to be CR, and half of it is going to be CW. So, one possibility is CR-CR, CR-CW, CR-DCW, and CW-CW. All right, we'll not worry about genotypic ratio on these problems, but you could do a phenotypic ratio and say, how many are red? Well, out of the 4, 1 is red. How many are pink? 1, 2, pink. And how many are white? 1. So the phenotypic ratio is 1 to 1. And incidentally, it's the same as the genotypic ratio. So this is incomplete dominance. Now, if you talk about codominance, codominance is a little bit different. So the way it would work, let's use a flower example. If you have label. Oh, excuse me, I'm a little tired. It's late Friday night and I'm still here at work. But here we go. Codominance. So incomplete dominance looks like this. Now codominance would look like this. CR would still be red. CW would still be white. But the difference is the heterozygote. CW would be red and white. In other words, some of the flower petals would be red and some would be white. There'd be no pink at all. So in codominance, both of these are together, like the copilot and the pilot are together. In codominance, both of the homozygotes are there in the heterozygote. This white is just as white as that white. That red is just as red as that red. Whereas in incomplete dominance, pink, there's no pink in here and there's no pink in there. This is like in between or a blend of these two. And that's the difference between incomplete dominance and codominance. So you'd get the same phenotype, or same phenotypic ratio. So in your notes on page 13, I made you color this. Whoa, it doesn't look red on the camera, but in person this is red. So in simple dominance, the homozygote, and I should put this also over here, and this is heterozygous, and this is homozygous. So in simple dominance, if you're like big B, you got blue flowers. If you're big B, little b, you still got blue flowers because blue flowers is dominant. That's how this relationship works. Now, if you've got little b, then it's red. And this is how simple dominance works. But if the flower was codominance, then one of the homozygotes is blue, one of the homozygotes is red, just the same. But the difference is the heterozygote. It has both the blue and the red. Then you have incomplete dominance. One homozygote is blue, one homozygote is red. So notice how these two columns are the same in all three of these inheritances. The difference is in the heterozygote. And in this case, the heterozygote is a mix of red and blue, because if you mix red and blue together, you get purple. And that's what that is.